this video, we're going to learn how to graph quadratic functions. In the first video, we learned how to solve quadratic equations. So when it is graphing, you use the word function. Graph quadratic function. When it is solving, you use equations. Solve quadratic equations. Okay, so quadratic equations. All right, let's just see what we have graphed so far. Okay, in the school year, we have graphed the linear functions, lines. So you could have a line leaning to the left. We say when slope is negative. Line leaning to the right when slope is positive. This one is a horizontal line. Slope is 0. And vertical line, no slope. Okay, so I hope you remember all of that. Now we also graphed exponential functions. It could be a decay, and there is an asymptote. Okay, I hope you remember the word asymptote, the line that your graph approaches closer and closer but do not touch. There's an exponential growth, and then if a is negative, okay, then this will be reflected over here. Okay, so this is a growth and this is a decay. So try to remember those things, okay, because you're going to meet them again in your algebra 2, and you're going to do that also in the SAT and the state testing. So the last one is quadratic functions. Quadratic from the word square. Okay, so we will graph the simplest quadratic function. Okay, that is the simplest. So we will call that the original function, or what we say, the parent graph. Okay, so that is called the parent graph. So you can also see in some books, they can also use f of x, or a function of x is x squared. They are just the same. As you could see in these graphs, these are all functions. They will follow the vertical line test. So with y equals x squared is also a function. So let's first graph y equals x squared using a table of values so we can see what this graph looks like. So let's give values for x and let's solve for the values of y. So let's give any value for x. Okay, let's start with any value. You could start with any. -4, -3, -2, -1, 0, 1, 2, 3, and 4. You could give more actually, okay? But let's just try with this. So let's substitute x, okay, -4 to square here. So pause this video and try to calculate. Okay, so I hope you already did. So you're going to substitute -2 as x, and then we're going to square that. Square means multiply by itself. So our answers will all be positive, right? Because when you square anything, it's going to be positive, except for imaginary numbers, but we are dealing with real numbers. So this will be 16, 9, perfect square, 4, perfect square, 0. And you notice here, it will go up again like this. So it will become 1, 4, 9, 16. Okay, so this one will go down and reach 0, 0, and it will go up again. Okay, so let's try to graph that. Okay, let's graph it, our first graph. Okay, let's try to see. So let's find our values. This is our x, y, and 0. Okay, so we can, I'm just going to ask you to, 16 is way up there, so maybe we can just graph from here up to here. Okay, these values. So let's start with, then we will just use arrowheads to say that it's going that direction. So -3, so this is -3. Okay, -3 is 9, So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 2 is 4. Negative 1 is 1. 0 is 0. 1 is 1. 2 is 4. That's also 4. So I'm just lining them up here. 3 is 9. So this is the graph of the function y equals x squared. Then we could have more points, but we are just using this 4. So what you do next is you try to make a smooth curve. It's not a line. It's not supposed to be straight line. Don't get your ruler. It's supposed to be curved, okay, like that. And that is what we call a parabola. This shape is a parabola. It's not a U, okay? There are certain things that has to be followed. You cannot just draw a U, okay? So here, let's study the different parts of a parabola. Let's study this parabola. As you could see, okay, this is the lowest point. Okay, that's the minimum point, and that is what we will call the vertex of the parabola. Vertex is the lowest or the highest point that we will see later. So our vertex here will be the origin. Okay, and then there is also what we call the line of symmetry. Symmetry is like mirror image. Okay, so you see, if you look here on the right side, okay, and then fold your paper, and you will see that you will see the same mirror image on the other side. So this is symmetrical with the y-axis. So the line of symmetry is the y-axis, or that is the line x equals 0. Y-axis, but that's a vertical line like this, so it's x equals 0. What else are we going to get here? Let's look at the x-intercept of this graph. X-intercept, where did it hit the x-axis, is 0, 0 here. That's also our y-intercept, because that is also where it hit the y-axis. Okay, and then let's find the domain of this function. Domain, all possible values of x. So you will see it comes from the left all the way straight to the right. So all real numbers. And range, what are our possible values of y? You could look at your graph. We will never have negative numbers here, only positive numbers. Or you could also look here. Okay, so you could see it starts at 0. The lowest point is 0, bracket 0 to positive infinity. So that is the parent graph y equals x squared plus 1. Okay, let's study other. Okay, so let's try to get the table. I want you to do the table for f of x. Let's say f of x. Let's use green. Or y is equal to, let's say, x squared plus 1. I'm going to put a 1 additional for that. Let's see what will happen. And then let's try again. F of x or y equals, what about if I put the, instead of x squared, I will put the 1 added to x. Here I added 1 to x squared. Here I will add 1 to x before I square it. So give the same values, okay? Give the same values. Let's start with negative 3. So let's make our x and y. So start with negative 3, negative 2, negative 1, 0, 1, 2, 3. Solve for the value here. The same thing here. Get the same. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. Okay, fill up the table. And I'll see you on the next video.